Hello parents and students, hope you're doing well. This is our second video on math. We're going to tackle the subject of perimeter. This is video M1.2, M for math, 1 for the first week, point 2 for the second video. Hope you enjoy it. So yesterday we talked about area. We went from concrete to abstract. Now we're going to look at perimeter. And first we have to define what a perimeter is. We defined an area yesterday as being how many squares we can put inside a rectangle. And we use crackers as our squares. Now the perimeter is the outside of anything. If you walked outside your house, you'd be walking around the perimeter of your house. Sometimes we use a can to draw a circle. This is a cranberry juice can. And we trace along the outside a bit. And we usually say, I traced a circle. Well, this is the perimeter of this can. You can also find the perimeter of the can going this way. It makes kind of an odd rectangle. Okay. These are both perimeters. I could use a Rice Krispie treat, and it almost has the same size perimeter as the can did, even though it's a different shape. But again, we're just talking about the outside. Now, these are really hard things to draw perimeters in, but hopefully you're getting the idea that the perimeter is this outside line. The area is in the middle. The perimeter are these lines that define the outside. Now, we had our crackers yesterday, and we determined there's 12 crackers. 3 rows and 4 columns make up 12 crackers. But we can do the same. We can find the perimeter of this arrangement as easy as we found the perimeter for our Rice Krispie treats, our juice can. We're just going to take and draw a line as best I can without moving my crackers. I'm trying to be as accurate as possible. Well, not easy. I hope you got some peanut butter yesterday. We had some peanut butter and crackers. Okay, so this is not easy to do. It's a little bit messy. But you can see I drew a line around my crackers. That's the perimeter of this arrangement. So I'm going to remove my crackers and just leave the line. I'm not focusing on the center. I'm just focusing on the line on the outside. This is our perimeter. Now we can measure our perimeter, and it's just as important to know the perimeter as it is to know the area. Now I'm just going to take a cracker and just kind of give an idea of how my crackers lined up here in my rows and columns. You can do this at home with your crackers too. And I have now we aren't going to deal with the inside, we're just dealing with the outside. I had 4 lengths of crackers this way and 3 lengths of crackers this way. 4 lengths of crackers this way and 3 lengths of crackers this way. We're not going to look at them as rows and columns. We're going to look as though this is a number line that is we folded our number line like we folded a ruler that's making our rectangle. So let's say this is 0 on our number line and we're going this direction. This would be 1 on our number line. This would be 2 and this would be 3, correct? If we were to have a number line here and just go 1, 2, 3, this over in this corner would be 4. So our number line goes to this corner, and then our number line is going to come down here. This number would be 5, this number would be 6, and this number would be 7. Are you following along? If I could take this perimeter and stretch it out into one long line and not have it wrap around our crackers, we could then measure the length of the perimeter. So perimeter is the length of all the sides. Area is how many squares are inside that shape. Now I got into 7 over here. I'm going to keep on going until I come back to where I started from, my 0 point here. 6, 7, 8, 9, 10, 11, 12, 13, when I'm back at 0, I've got 14. This is not 140. I started with 0 just to count like on my number line, but when I got back to 0, that corner was the 14th length that I had to include in my number line. So my perimeter is like counting on a number line. My perimeter for this particular shape is 14. So I've switched to some graph paper here. This is on an erase board. And this is very handy for determining both area and perimeter. We're just going to use it for perimeter. And I'm going to draw a random rectangle. I'm just going to go down. I'm not even going to count. I'm just going to kind of draw one in. You could do this at home on graph paper, and I'll show you an example on graph paper. There's my perimeter. Now, there's no object inside like I showed you before because we're getting a little bit more from concrete to abstract. So this is an abstract representation of a perimeter of something. Doesn't matter what it is. We're just looking at how to determine mathematically how this is going to work. So I'm going to count. The squares are already in there. I'm not going to worry about the squares. I'm not going to worry about the area just yet. I'm going to worry about the perimeter. So I'm going to put my 0 here. Remember, I'm going to go all the way around and come back to my 0. I do have to count that spot where that 0 is because it's almost like this is where the number line ends. It's like 0 is right here and my end of my line is going to be right here. So there's a little bit of a break there. That's also a little bit imaginary. So you're going to have to put your thinking caps on and think abstractly that this is a number line in length. And we're going to count our number line. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to this edge, 11, 12, 13, 14, 15, 16 down this corner, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. It's getting a little messy. I'm down here at 26. I'm going to go up. 27, 28, 29, 30, 31, and 32 brings me right back to this corner where I started from. So the perimeter of this rectangle is 32. That would be my perimeter. So you're going to need a pad of graph paper. I will supply you one sheet of graph paper with the packet for this week. But you'll probably, when you go and buy some line paper, get some graph paper as well. This is really handy for making models. So here's my line graph paper. I'm going to zoom in so you can see the lines here. And you won't need a ruler, but you might want a ruler as well. And I'm just going to make some random rectangles. Again, I'm not counting yet. I'm going to make one that goes this way. Okay. I could make one that's long and skinny. And remember, we're going from concrete to abstract. So now I'm just putting random rectangles on here. I'm going to count the squares, or the sides of the squares, because remember, we don't have to count how many squares there are in the middle as long as we know our multiplication tables very well. I'm going to count this one side here, that's the rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 over here. I'm going to start my corner over here and count this direction. 1, 2, 3, 4, 5, 6. Just like I'm counting on number line. So this rectangle is 9 along 9 rows by 6 columns. This one here is 3. I can see that right off the bat here. I'm going to have to go and count a little bit to get these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my goodness, 12. All right. Now I'm just going to use my equations to find perimeter. Down here, I'm going to use, remember, we have 4 sides. So we're going to be adding 4 sides and coming up with some of the add-ins, we call these numbers. Some of the add-ins. So for this rectangle, I have 9, and I have 6, and I have 9, and I have 6. I have 9 here, I have 6 here, I have 9 here, and I have 6 there. Even though I haven't written in these 2 numbers, I know I'm adding up the sides. And there's 4 sides, so I need 4 numbers in each space, and they're going to repeat themselves. 9, 6, 9, 6. Over here, I still need the same thing. So operation has changed from multiplication to addition. Kind of ran out of room here, so I'm going to make this my equal sign. You're going to be sloppy too. Don't give me that. Move this over a little bit so we can see it a little bit better. So here I have a 3 and a 12. So I started from here and went up 3 over 12. Here I'm going to have a 3 and a 12 also. So you can start with whatever corner you want, but your pattern better look the same. If this pattern doesn't look the same, then you've done something wrong in the beginning. So now I'm going to use my strategy for addition. Over here, I'm going to use my 9 and 6. I'm going to add these 2 up. So I'm going to put a little caret down here, and I'm going to say this is 15. And over here, I'm going to say this is 15. I'm going to add those together, and I know my sum's going to be 30. 15 plus 15 is 30, so I know this is going to equal 30 as far as my perimeter. This one I have my 3 and my 12. This one's going to equal 15 as well. And this one's going to equal 15. And my sum of these 4 digits is going to equal 30 as well. So even though these 2 shapes are different, they have the same perimeter, 30. So experiment for a little while each day with your graph paper and make out random rectangles, and you may see some amazing things that happen in math. Practice your areas, practice your perimeters, come up with the answers on your homework, on your work packet, and we will collect those later. I hope this video was helpful for you guys, and I'll put together many more as best I can. It's not easy doing this, but it's not easy in the circumstances where you're at too. So we're all in this together. Let's be friends.